Okay guys, so we are going to be looking at visualizing data. And this is going to be a two-part series and maybe even a three-part series. In the last part of the series, we're going to look at a full project. So we're going to look at the General Automation Model, and we saw some of this in the intro videos. And we're going to be looking at its two halves, the General Sensing Model and the General Actuating Model. In this video, we're going to be looking at the sensing model and how to visualize data. We're going to look at simple versus complex data, and we're going to introduce the LCD. And at the end, in the third part, we're going to look at a full project that brings in both sides, the sensing and the actuating model together, to complete the general automation model. And this is going to give you guys an idea, or a basis rather, for any project that you might think of. So, okay, let's get into it. So, this is the general automation model. So, we can sense stuff using all the different kinds of sensors that we can think of, much as we would with our senses in our body, and process that data or analyze it with a microcontroller, and then we act on it. And we're going to look at some of the actuators that are available as well. In this case, we have a robot hand, but there's quite a few. Okay, so let's get started. What we're going to do is we're going to look at quite a few different projects and sketches, first in serial monitor and then on LCD. So hello LCD, this is the wiring diagram for an LCD. Don't worry about the sensor right now. All we're going to do in this first LCD screen. So I have here a very simple sketch, the most basic for the LCD screen. And these first three lines are the most important ones. So the first one includes the LCD library. The second one is something just for contrast. The third line declares the liquid crystal LCD object. Then we initialize this stuff. We set the cursor, and then we write to the LCD much in the same way we would write to the serial monitor. Okay, so this code is going to be down in the description, and let me just highlight the whole thing, copy, bring it over here, paste, and there it is. Okay, so let's take a look at a Hello World example for the LCD. We click on Upload, and it blinks, and here it comes, there it is. So that's how we get data onto an LCD. Okay, that's pretty cool. Now that we know how to do that, let's go ahead and modify, or to learn how the DHT11 example. Let's copy these three lines over. I already have them there. Over to our DHT11 example so we can present the data on the LCD. Okay, so this is the data that was the lines of code that were already on the DHT11 sketch. This is a new line, the contrast line. This is also a new line. And this is also a new line. Okay, and then we are going to leave the data, the lines that were already there. And over here we are setting the cursor and writing to the correct rows. All right, so code looks good. Let's go ahead and select all of it at some point over here. So let's actually select the code and copy and paste it in the sketch window that I said we were going to use, which is this one. And now we can click on Upload. Okay, perfect. So there goes. And as it writes to the MCU, the screen is going to blink. And here is our data. Voila, humidity and temperature right there. All right, cool. So now we know how to write to an LCD screen. This makes projects a little bit more informative, more easy to visualize and interpret as well. And it's also much more efficient to have data shown to you on a screen than it is on a computer. Okay, so here's the simple connection. It's just the DHT11 signal cable. And this opens a lot of opportunities for a lot of the projects we can do because this LCD screen is pretty small, compact, and not very heavy at all. And we can port it to any of the projects that we work on. So we are going to try out quite a few different sensors that we have here on this board to explore the sensing model while we um, get a better feel for this LCD code stuff. All right. Okay, so let's look at the next one. This is the ultrasonic sensor. This is very popular. So this is used on cars. It's used on. It's also used in a lot of projects where you need to detect not only longitudinal distance but also vertical distances. So you can measure height with this stuff. Okay, so you saw the wiring diagram. You can go back and look for it if you look at it if you want. I'm going to quickly plug in the 5 volts and ground, and the two cables that are left are the trigger and echo. So one of these sends out a signal, the other one captures it, and the difference in time and that from the emitted signal to the received signal is what gives the MCU the ability to calculate distance. So, okay, so let's plug this trig pin over here, the echo one over there. All right, and okay, so now we're pretty much ready. All right, so we're going to use this as our target or object, or obstacle rather. And let's go ahead and scoot over to the ultrasonic, copy the code, paste it, and now it's already ready. So let's upload it and open up the serial monitor. Okay, so there it is. Distance of 4, 5. Okay, as you bring it in closer, it goes down to 3 inches. And as you bring it out, 8, 9, 10, 50, 100, 200, all the way out. And then just boom, right in front. 4 inches. Okay, great. This is great data to see on a serial monitor. I mean, this is data that we would definitely want to see on an LCD screen. And we're going to go ahead and upload the code that we have for the LCD screen and compare. And here it is, LCD flashing. There it is, distance, and we have 2 rows, one of them in centimeters, the other one in inches. So there's 4 centimeters, there's 6 and 3 inches, 6 inches. It goes out to 59 inches. It's actually looking at the wall. And there it is. Okay, so we have looked at 2 examples of loading code up to an LCD screen. And the cool thing about this is that you only need 3 lines at the beginning, like we reviewed, and then the LCD.begin in the setup, and the LCD.setCursor to place your cursor wherever you want to write, and finally the LCD.print, which is basically what you use to print out data onto the screen, much in the same way we did with the serial monitor. And it's that simple. Alright, so let's go ahead and look at the next sensor. Okay guys, so we're going to look at the infrared sensor. Okay, so this detects infrared radiation. It's very popular in remotes. Okay, so it has 3 pins, and the first one is VCC, the second one is ground, as usual. So we're going to get those plugged in first. The third one is obviously the signal pin. So let me plug these into the power rails first. And we already have power coming out of the Arduino into these rails, and now onto these rails and onto the infrared sensor. Let me get this bunch of cables out of the way so you guys can see more clearly. And here is the infrared sensor. So we're powering one board from the other, and the other side over here. Okay, so let's go ahead and see what this looks like. And here's the code. I'm going to copy and paste it over here to our upload sketch. Place all that code, and this is going to be the serial monitor example. So here it goes. It's uploaded, and let's go ahead and open the serial monitor to see what the data looks like. And there it is. uploaded finally. That took a while. Okay, and we're gonna grab a remote control, just like any remote control you'd find laying around in your house, and here it is. So I'm gonna be pressing a couple of buttons down here. There's one, you can see the code. There's a second one, a different one. There's a third one. So each one of the buttons has a different code, and that is what we are basically saying whenever we press a button. Okay, so the IR sensor is able to read that data and decode it and spit out whatever code it was programmed to send whenever that button was pressed. Now we're going to select that code for the LCD screen, upload it to the Arduino, and display it on the screen. And there it is. You can see the LCD blinking, and now there's the IR code. And whenever we press a button on the remote, the IR code changes to whatever the said button is programmed to do. Alright, so just another example of how much better it is to visualize data on an LCD screen than it is to do so on a serial monitor, which would obviously require the presence of a computer connected to your project all the time. Okay, great. Now let's look at a pH meter sensor, which is great for a lot of scientific stuff. Okay. Okay, so we are going to look at this pH meter module. This is the circuit board, and as you can see, it has the digital pins on the right side here, and we're going to connect the VCC to the 5 volt and the ground to our ground, and you can see the LED light up on the circuit board for the pH meter. Now this is the actual electrode, or sensing electrode as it is called. This is the part that goes into the solution, and as you can see right now, it has a cap, screw-on cap with a saline solution to keep it wet, because these things will ruin if they dry up. And it has this BNC connector that plugs into this side. Okay, we're going to look at a lot of different connectors, like the barrel jack connector, the 3.5 audio connector, BNC connectors, and even USB connectors for power. They're very useful depending on the different applications. So let me go ahead and organize some stuff around here. And now we need a cable for the actual data pin. And we're going to plug this into A0, which, if you recall, is analog 0. There it is. And okay, so we're ready to upload the code and test this. Wait for it to upload and then open up the serial monitor. And we can see 6.9 pretty consistently. That's supposed to be a neutral solution at 7.0, so 6.9 is pretty close. Alright, that's great. And now let's go ahead and copy and paste the code in for the same sensor onto the LCD screen. There it is. And hit the upload button for that sketch. And here it is. The screen is blinking, and voila. So we have pH. In this case, we could use it. Could be using this for a kombucha project, or for a beer project, or wine project, whatever we want. And this is what we are measuring with this sensor. Okay, and this is perfect because we can very simply hook up one of these LCD screens to some plastic container and attach it to any kind of batch tank wherever we might be monitoring our parameters, and it's very visible. Okay, so let me go ahead and take this apart, and we are going to look at something called Grove, which is a system of sensors and Shield, which make sensing or analyzing certain data, the more commonly recorded data, a lot easier. So here is the Grove kit, and as you can see, it comes with a lot of sensors and it comes with a shield. And the shield has quite a few connectors for the different sensors, and it has the same pinout for the Arduino Uno in this case. So this basically fits right over your Arduino Uno and allows you to plug in quite a few different sensors such that you are converting your Uno into a station. So let's get this Uno out of the way with the LCD screen and look into the Grove kit and the Grove Shield. However, before we take it apart, we are actually going to look at one of the Grove sensors directly on the Arduino. That way we can compare the differences between using sensors directly with all these wires and using it on something like a shield. So we're going to plug in VCC and ground of our sensor, and this third pin, as usual, is going to connect, in this case again, to analog 0, which is A0, and that's the signal pin for the sensor, and this is the sensor right here. This is a UV, ultraviolet sensor. Let me see if I can hold this down like that, and let's go ahead and upload the sketch and take a look at what kind of data this produces. Here is the serial monitor, and here is our data. Now there are 3 different ways of measuring in this case, and I have actually used all 3, but you could probably see that we get one of the indicators as 425.93 and the other one is 627, and that's pretty consistent for indoor UV. And we're going to take this outside so you can see the difference. But now we are uploading it onto the LCD, and here it is, the UV alarm system, UV index 425.93. That's the data I was talking to you guys about. And there's a way to convert this into the UV index that you usually see in news programs and whatnot. But so we've managed to get this data from the sensor onto the LCD, and this is very useful for making UV alarms that people might want to carry in their car or take camping with them, or when they go to soccer practice. A lot of parents are very careful about what their kids are exposed to, and that's perfect for this application. Okay, let's look at shields. So the Grove Shield, as I mentioned, allows us to connect quite a few different sensors to one Arduino board. Here are 2 shields. One's a Wi-Fi, we'll take a look at later, and this is the Grove Shield I mentioned. So we have a free Uno right here. As you can see, it's very easy to put on. Just be careful with the pins. Again, they're delicate and sometimes they bend. Okay, so we use these connectors up top to plug in our sensors. And in this case, it goes into the analog 0, which is right here, A0. And you get that in there. Also be careful with these pins. The smaller they are, the weaker they are. So there it is. And that's our sensor. We are now going to upload the data for this sensor with the shield and power up. As you can see, the Uno powers up and so does the shield, as you can see from the LEDs. And now let's compare and see if we actually get the same data. Remember, we're not changing anything. The only thing we're doing is connecting the sensor through the shield in this case, instead of through direct jumper cables. Alright, so here is the serial monitor, and as you can see, the same data, 403.51 and 594, and in the second round 403 is now 403 again, and here is the data that I promised for the outside exposure. So this is jumps from 403 to 440, and then back down to 418 and finally back down to 403. So you can see the data changing when we take this shield with the sensor outside into the direct sun as compared to inside. Alright, so this is the Grove Shield, and as you can see, you have a lot of slots here for different sensors that you can pick from in this box and outside of this box. There's sound sensors, there's touch sensors, humidity, air quality, there's dust, there's even sensors for humidity. You can build your own weather station or air quality monitoring station for warehouses, factories, etc. Okay, so let's be careful when removing the shield. Don't want to bend those pins. You really shouldn't do this while the Uno is plugged in, but just so you know. Okay, so let's put the shield away. We're done with that. Okay, so let's talk about more complex data. As you might recall from a previous video, this was a coffee humidity sensor. It has an LCD, circuit board with a nano that is connected to a DHT22, and it takes instantaneous measurements of humidity of the parchment coffee that's inside the cylindrical container on the left. Now, what if we want to take data for over a long period of time? Well, then we have something like this. This is EMON CMS, Energy Monitor Content Management System. You can install on a website, or you can use a free one as well, I believe. And here we are recording data from humidity and temperature for ID4 and ID5 in real time. And it updates every 180 seconds. You can see in the updated column, which is now at 174, and the values on the right are 43.5 for humidity, but when it reaches 180, it takes a new measurement, and 43.5 changes to 43.8. And the data keeps logging on as long as the sensor is feeding the data onto a microcontroller. And we can see this time series in this data viewer. As you can see here in the beginning, I remember we actually had a power outage for a few days. Okay, and another kind of complex data is, for example, gyroscope or spatial orientation data. This is the MPU 6050, and we will take a look at a project with this in the future, and we use this in the car kit series when we controlled the car with the glove. And what it does is it provides information of the different axes. So, for example, if the sensor can be rotated in this direction, forward and backwards as well, or it could rotate on its axis, then those 3 degrees of spatial information can be fed onto the Arduino and then processed by, as we can see here, we are using a program called processing, and the sketch feeds the data into the Arduino and then into processing, which draws a 3D figure, which in this case looks sort of like an airplane. And as I move the MPU 6050, the data is used to move the 3D airplane. Okay, great. So that was the sensing side, or the general sensing model, and we will look at the actuating model in a future video. Okay, so I really hope you guys enjoyed this video. It gave quite a few examples of sensors and how to display simple data on an LCD or complex data on something like a content management system or a 3D rendering program. Okay, so don't forget to like, share, and subscribe. See you next time.